Let ABC be an acute triangle with circumcircle T. Let the internal bisector of angle BAC intersect BC and T at E and N, respectively. Let A' be the antipode of A on T, and let V be the point where AA' intersects BC. Given EV equals 6, VA' equals 7, and A'N equals 9, compute the radius of T. We have triangle ABC here with circumcircle T, and we're given that the internal bisector of angle A intersects BC at E and T at a second point N, while the point opposite A on T is A', and AA' intersects BC at a point V. We're given that EV equals 6, VA' equals 7, and A'N equals 9. We want to compute the radius of T. We're going to use this method of force overlaid inversion, which I brought here from EGMO. It says let ABC be a triangle, and consider the transformation consisting of an inversion about A with radius the square root of AB times AC, followed by a reflection around the angle bisector of BAC, which fixes B and C. This is what we're going to do in triangle ABC. I color-coded the points where we are going to do inversion. Let's start with N and E. It's well known that they are swapped under this force overlaid inversion, also known as root BC inversion. So we can let N equal E', where prime refers to a point after its inversion, and E equals N', because E is sent to N, and N is sent to E. Now let's do A'. It's well known that A' is sent to the foot of the altitude from A. Let's call that D, and it's over here. And we'll call this D. It's equal to A', prime. And then, finally, we have to do inversion for V. That's simply the point on line AD that lies on the circumcircle of ABC. It's this point out here. Let's call that F. So we have to use this color. Let's call this point F equals V', where all three of these points lie on a line that is perpendicular to BC through A. Now we're ready to find Fn. We know that line AF has the orthocenter of ABC somewhere on it right here. And the midpoint of line AA' is the circumcenter of ABC. And the circumcenter and orthocenter are isogonal conjugates. So lines AF and AA' are isogonal. And that means AN, which is the angle bisector of angle A, is also the angle bisector of FAA', which means that Fn is simply equal to NA', which is 9. So we can express this here as 9. But we can also find Fn in a different way using the inversion distance formula, which I brought here from EGMO. And that is Fn equals V', E'. F is the root BC inverted image of V, and N is the root BC inverted image of E. So it's V', E', and that's equal to R squared. The radius of inversion was the square root of AB times AC. So R squared is AB times AC over AV times AE times VE. Now Fn is equal to 9. We know that from here. And that's equal to AB times AC over AE over AV. AB times AC over AE is just AN because E is sent to N. So that's just AN over AV, which is just 2R minus 7. AA' is 2R. We're asked to compute the radius of T, so we're expressing everything in terms of R. AA' is 2R, AV is 2R minus 7. And that times VE, which is 6. So we have 9 over 6, which is 3 over 2, is AN over 2R minus 7. And so we have AN is 3R minus 21 over 2. So now we know what AN is, and we know that ANA' is a right angle because AA' is a diameter of T. So we can actually apply the Pythagorean theorem on triangle ANA'. So we have AN squared, which is 3R minus 21 over 2 squared, plus NA' squared, which is 9 squared, and that's equal to 2R squared. Let's multiply everything here by 4. We get 6R minus 21 squared plus 18 squared equals 4R squared. Now 6R minus 21 squared, that's 36R squared minus 252R plus 441. And then 18 squared is 324. That's equal to 4R squared, which is 16R squared. Now, subtract 16R squared from both sides. We get 20R squared minus 252R plus 441 plus 324, which is 765, is equal to 0. We can factor this. It ends up being 2R minus 15 times 10r minus 51 equals 0. So r is either 15 over 2 or r is equal to 51 over 10. But we have to choose the larger value of r because the smaller value of r will result in ABC being an obtuse triangle, and it's given in the problem statement that ABC is an acute triangle, so r is equal to 15 over 2. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.